In today's video, I would like to introduce you a very nice problem of Bulgarian Mathematical Olympiad edition 1977. Here is the following information. Find all integers numbers x such that we have this number x squared plus 1 divides x cubed minus 8 times is multiplied by x squared plus 2 times x. Okay? In fact, this is very straightforward problem. Doesn't need any trick or a higher technique. We are simply going to factor out this one and make the connection between this one and this one to check this one divides this one. Okay? And then we determine which condition can make this one divides this one. Okay? As an integer number. Before I proceed with the solution, don't forget to support us with your like and subscribe. If you would like also to give a hand to this problem, go ahead, pause this video when you come back to see the full solution. Okay? Let's get into the solution now. So according to the algorithm Euclidean, I'm going to do this one, x cubed minus 8x squared plus 2x divided by x squared plus 1. Okay, so x cubed divide x squared is given as x here. To make x is multiplied by x cubed is given as x cubed here. X is multiplied by 1 is given as x plus x. Now I'm going to make the difference of these terms. This one is 0. This one is given as minus x squared minus x. I'm going to bring this one down here. Plus 2x. I'm going to plus 2x minus x plus 2x is given as x plus x. So here minus x squared is divided by x squared is given as minus 8 here. Minus 8 is multiplied by x squared is given as minus 8x squared. Minus 8 is multiplied by 1 is given as minus 8. I'm going to make the difference here. It's given as 0 here. This one is given as x plus 8. Okay, as a reminder. So now I'm going to make this one equals to this one is multiplied by this one as a quotient. I'm going to make this one as a quotient and this one as a remainder. Okay, so now I will have x cubed minus 8x squared plus 2x equals x squared plus number 1 is multiplied by x minus 8 plus the remainder, which is x plus 8. Okay, now I'm going to divide this one. I'm going to divide both sides by x squared plus 1. X squared plus 1. X squared plus 1. X squared plus 1. Okay. This one, it will be cancelled out with this one. I will be left with x minus 8 plus x plus 8 is divided by x squared plus number 1. Okay, since this one divides this term, that means this term is an integer. That means the right hand side of this equation is an integer as well. Since this term is an integer, this term must be an integer as well. This term must be an integer. Okay, in order to have this fraction as an integer, we must have x squared plus 1 divides x plus 8. Okay, in order to have this term divide this one, that means numerator must be bigger than denominator. Okay, so but the problem, we don't have x is strictly superior than 3, the denominator gets bigger. Okay, we don't have x is strictly superior than 3, the numerator gets smaller than denominator. So I will have x plus 8 is strictly inferior than x squared plus number 1. Okay, since the numerator gets smaller than denominator, impossible to have x squared plus 1 divides this one. So this one is telling us in order to have this one as an integer, we must have x is inferior or equal to 3. Okay, we contradict this assumption. Okay, because by using x strictly superior than 3, never ever to have this divisibility verified. Okay, so x must be inferior or equal to 3. If x is inferior or equal to 3, that means x will take the following values. It's taking minus 2, minus 1, 0, 1, 2, 3. because it's taking negative solutions as well. So the solution which verify this divisibility statement, we must hold numerator always must be bigger than denominator. Okay, we are going to check, because if you check all these values are holding this inequality, this one bigger than this one, otherwise you will have this term, otherwise you have numerator smaller than denominator. Okay, I'm going to check one by one. So I'm going to start with a negative one. Okay, so by checking x equals minus 2, because if you take in x equals minus 3, then we replace minus 3 here. Minus 3 plus 8 is giving us 5. I'm going to replace minus 3 here, is giving us 9 plus 1, which is 10. So that's mean numerator is smaller than denominator, which is impossible. Okay, so that's why I take x equals to minus 2. X equal to minus 2, 8 minus 2 is giving us 6. Denominator, by replacing x with minus 2 here, is giving us 4 minus 5. So we'll have 6 is bigger than 5. Okay, even if you replace the denominator with the negative numbers, is always you get a positive here, because we have square here, and the power of 2 make the numbers going quickly up. So x equals minus 2 is not a solution. I'm going to check x equals to minus 1. X equals minus 1. Minus 1 plus 8 is giving us 7 in numerator. Minus 1 in denominator is giving us 1 plus 1, which is 2. Okay, that means 7 over 2. So that means 2 not divide 7, which is impossible. We are not going to take this one also. I'm going to check x equal to 0. Okay, x equal to 0, 0, 8, 8. That's mean 1 divide 8. That's okay. That's mean x equal to 0 is a solution. I'm going to check x equals 1. So with x equals 1, that's mean 1 plus 8 is 9. In denominator we get 1 plus 1, which is 2. 9 over 2 is not an integer. Okay, that's mean this x equals 1 is not a solution. I'm going to check x equals 2. Okay, x equals 2. 2 plus 8 is 10. In denominator I get 2 square, 4 plus 1 is 5. So that's mean 10 over 5, which that's mean is an integer. Okay, that's mean x equals 2 is a solution as well. Okay, let's check x equal 3. X equal 3, 3 plus 8 is 11. In denominator we'll get 3 square, which is 9, plus 1, which is 10. Okay, I will get 11 over 10, which is not an integer. Okay, so x equals 3 is not an integer. So only the solutions that I found, x equals 0 and x equals 2. Okay, so I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.